Welcome. So this is another sequential logic circuit design exercise taken from John F. Wakerly book. So here we have to design a state machine with two inputs and a single output. So two inputs are A and B, and if we take two consecutive ones or two consecutive zeros in our A, we will set our output set as 1. Okay. Uh, the alternative condition is that if B has been 1 since the last time that the first condition was true. Okay, so how to design this one? So usually we can do it using state transition diagrams, and we can design it like this, right? What we have here is essentially a sequence detector where we detect two consecutive zeros or two consecutive ones. Okay, from initial condition, we can take our two inputs as A, B in that order. So if my A is 0, regardless of B, I'm going to a state where I have single 0 at my input A. In this state, I have two zeros in a row in my input A regardless of B. Okay, so here I have A1, which is representing 1 A equals 1 in our uh, system, and the second here we have two consecutive ones in a row in our input A. Okay, so from there we can decide what to do for the second condition here. What happened with the B, right? uh, and also in the middle we have here, like if we have a single one and if we have a zero in the next clock signal or clock tick, then we have to go to a zero, right? Because we only have one zeros in a row in that case. So yeah, this much you can do, but after that you can decide what happens with our B input, right? So now if we reach A00 or A11, we can actually set our Z to 1 as required in the output. Okay, but what about the uh, o- outgoing transitions from A00 and A11, right? So this is about the second condition about B. Right? For example, if I'm here at A00, again I have four outgoing transition conditions, right? 0001. Others are 0001, 1011, right? So how can I design for that all the outputs for these two, right? So if my A is 0, I can still remain here because that means it will be the third consecutive 0 or fourth or fifth, right? It does not matter. As far as I have two consecutives in a row, I can stay in the same state regardless of my B. Okay, here it's the opposite, where if I have three or four or five consecutive ones, I can stay in the same state here. Okay, but what happen if I get a 0, or what happen if my B is something uh, in the sense like 0 or 1 with my A is 0. So that those are the conditions I need to consider now. Okay, so there are various designs we can do here. One may be simple and one may be a little bit complicated. Okay, so let's instead of going through with the state diagram itself, let's go with a what we call a state table in this design. So it is another representation of our state transition diagram. So state table is something which represent the state table itself, right? So we have a initial state and we have a input condition based on this input condition, we can go from our initial state or whatever the state to the next state, right? Also, we can define the z, which is the output. Okay, so far what we have designed is a sequence detector. So based on that, I can fill this table, right? If I am in the initial state and if I get 0 0, where am I going, right? So I could go to a 0 state, right? Others would be, if I get 0 1, still I have here 0 1 also, I am going to a 0, right? Then if I have 1 1, I will go to here, right? 1 1, I'm going to a1, 1 0 also, I'm going to a1, a1, a1. And in these two states, we are not we are not keeping our z as 1 also. This is also not 1, right? All three states we have z as 0 because we didn't meet the condition yet, right? We didn't meet the condition yet. So okay, so now we have identified two states here. Now I can have them got 0 on a, got 1 on a. These are a0, a1, right? So how can I do the transitions for the outgoing transitions from a0 and a1? So let's consider that one also. If I'm at a node, right? If I get 0 0, where am I going, right? I'm at a node and I'm going to a 0 0 if I get input 0 0, right? So I'm going to go to a 0 0. Okay, from there you can also consider other states as well. From here, if I get 0 1 1, I'm still going to a 0 0. Okay, but if I get 1 1, that means I have only one consecutive ones in my input a, so I'm going to a1. Okay, whereas I have 1 0, still I'm neglecting my b, right? Because my a is 1, so I have only one consecutive ones, so I can still go to a1 and the output is also 0. Okay, so how about the a1? It is similar but with a11 in this case, right? If I have 0 0, right, I have to go to a naught. Okay, this one also 0 1 is also I'm going to a naught, a naught. Then I have 1 1. In that case, okay, I have 1 1 or 1 0. That means my a is the second consecutive one in the a input, so I can go to a11 in this situation. Okay, I'm still at a1 state, right? Which means my input output is also 0. Okay, but here these are my a00 and a11 states, which represent my two consecutive zeros in a row or two consecutive ones in a row uh, state. Okay, so from there, where do we go? That's the next concern, right? So let's see, if we have 0 0 and we are at our input also 0 0, so this is this two, right? So this will be the third or fourth or fifth consecutive 0 in a row in my input A. Okay, so I will stay in the same state if this is the case. Okay, 0 1 also, still I'm staying in the same state. Okay, so these two we didn't consider. Let's see, like it will be a little bit tricky, but you can consider what happens there also. But let's fill the details available in this one now. So I have a11 1 0 1 1, right? That means third or fourth or fifth consecutive one in a row in my input A, right? That's what this loop means, right? So it also depicts my first condition here. he had the same value at each of the two previous clock ticks. So I can go stay in the same state regardless of my input B. Okay, so I have these things to fill, but nevertheless we can have my output as 1 in these two states as well. Okay, so where do we go from there? That's the next concern, right? So if you complete this one, you might find something like this also. So this one, in this case, I have indicated some of my logic using another two states where my uh, 1 1 and outgoing 1 0 is depicted here, right? So I have 1 0 going out to A1 and 1 1 going into another state here, right? So we could design it in various ways. So up to here it is actually the same for both of these states, right? So I will just copy this one, okay, to here. Okay, so if this is the case, then I can decide where my other outputs are going. So let's fill this one instead of this one, because I mean, thinking could be a little bit tricky, because in here, let's consider this one. Okay, so here I have my remaining input conditions, right? 1 0 and 1 1. If we have 1 0, what will happen from here, right? We have 1 0, that means my B is 0, that means I am not in the second condition, right? So maybe I can still write it uh, saying that I had some consecutive zeros in a row, but now I have 1 in my input. That means I have to go to shift to this side somehow. I mean, it is the first consecutive one in a row, so probably I can go there, right? But what about the B? In B, I have 0, so that means I'm not in the second condition, right? So it is kind of obvious. So let's write that also. Okay. So I'm going here if I have 1 0. Okay. So what about the rest? So it could be here. Let's consider here. I have 0 1 0 1 1 already considered. What if I have 0 0, right? 0 0 means we are breaking our consecutive ones and we will be going back to A0, because we are getting a 0 in our A input, right? Here this is 0 also, uh, uh, because in B equals 1 we have a different thing to consider, right? So now let's consider what happens with our B. Okay, so now what is remaining here? We have remaining uh, which one is it? 1 1, right? What happen if we get 1 in our B and 1 in our A, right? Probably we can go from, I mean, if it is uh, single consecutive, I mean single one in a row in our A input, it is not useful to set or it is not satisfying our condition to set z equals 1, right? So but still, in because B is 1, we have to remain in a state where our z is 1. So one option is to get another state here, right? That's what I have drawn here in this one. So here what we have is, with 1 1 I'm going to another state where I have equals 1. So this is also another state which is z equals uh, 0. Okay, so now let's build up this condition here. Okay, so now I have two another states, okay A0 and okay A1. So let's fill this up now. Okay, So now I am at A00 and I'm going back to I get my input as 1 1, which means I am at OK 0 0. I get input 1 1, so I am going to a state called OK A1. Okay, OK A1. Now if I get 1 0 1 0, I am going back to A1. So my B condition is not met, so I have to reset my circuit, right? So I'm going to A1. So that part is clear. Then what about at A11? A11, yeah, this OK is actually A11 or OK00, it's the same, right? So you understand that part. So yeah, so this could be OK00, okay? Yeah, it's not matter the name much, but yeah. Okay, so what happened from OK11, OE11 to I'm getting in my input as 0 0. If it is 0 0, that means my consecutive set of ones are broken now, so I have to go back to a single 0, right? That's A naught, right? So I'm going to A naught here. Okay, then I have 0 1. 0 1 is I have multiple consecutive ones in a row, but my now I have broken my pattern because I have 0 in my input A, but my B is 1. That means I have been in this state, which means my at least I had two consecutive previous clock ticks where my A is 1, but now I have B equals 1, so I'm staying in the state where my Z is 1, right? So that's what OK 0 is here. So there I can go to OK A 0. Okay. So now let's again consider what are the outputs we are going from here, right? So let's say we get 0 0 from here. That means I came here from 1 here, right? Which means my output, I mean my A is 0, means it's only first 0 at the first clock tick, right? Previous clock tick it was 1, right? So that means my B is also 0, so I cannot stay here because of the second condition. I cannot stay here because of the first condition as well, because it changed, right? So I'm going back to single 0 at my A, right? So it could be A0. Okay, so how about this one? I have now I'm considering 0 1 from my OK A0, right? Okay, sorry, this one is actually OK A1, right? So yeah, OK A1, right? So what is the next one? 0 1 from here, right? If I get a 0 here, that means uh, my first condition is not met, but B is 1, right? That means I have to stay in one of the locking state, right? So because of 0 1, I'm going to A0 OK state, right? So you can write it here, OK A0. How about 1 1? If I'm here, I get 1 1, right? I get 1 1, probably I can go back here because now my first condition is met already, right? But so I don't need to stay here based on the second condition. I can go back to here to stay in OK 1 1 or A11 state based on my first rule, right? Because I have already two consecutive ones in a row. Okay, so I'm staying here as A00, sorry, A11 state because I have two consecutive ones in a row. Okay, so here a11, here I have OK11, but yeah, it's the same. Okay, how about the last one? So this is at OK1 state, and I have an input of 1 0, right? So second condition does not satisfy, right? But my first condition is satisfied, right? So still I can go back to one or two consecutive ones in a row. So I can still go back to A11 based on first rule. Okay. So yeah, logic is a little bit complicated here, but I mean you have to somehow think and come up with a design which capture all the possibilities in our given description, right? So that's the idea. After that we will see what we can do to simplify this. Okay, so now I'm at OK0, okay, A0, and from there what is the output if I get 0 0, right? So I have three or more consecutive ones, and now I'm here because I have came here based on my second condition, right? Because first condition is violated, but I have the second condition. Based on that, I'm here. And if I get 0 0, I have met again the first condition based on a equals 0, right? So I can go to OK 0 0. So here I am writing it as a 0 0. It's the same. Okay. So 0 0, 0 1. 0 1 also I'm meeting my first condition because I have two zeros in a row. So I'm still going to a 0 0. I'm at OK a 0, and my next input condition could be 1 1, right? If I'm at 1 1, so I have two consecutive ones, right? So no, sorry, I don't have two consecutive ones at a row, right? I have only 0 here, right? But I have 1 here. That means I don't have two consecutive ones in a row. So first condition it is not met, but I have B1, right? So based on my second rule, I can stay in a locked state. Okay, A1. Okay, okay, A1. And next one would be 1 0. What happen if I'm here and I get 1 0? So I came here based on my A is 0 and B is 1, but now my B is broken. So second rule is not satisfied. First rule is also not satisfied, right? That means I only have one ones in a row in my input, so I have to go back to A1. Okay. So in this both of these conditions, so states also, what I have is my output is z is 1, right? Because based on second condition I can say that my output is 1 here. So this is my state table and this is my state transition diagram. Okay, so now we are happy that probably we can already implement it, right? But can we fill this up instead, right? Is there a way to fill this up? So we can think about this. So that's why we need a, a state transition simplification method. We can think and maybe we can find a way to simplify it. So in next section, let's see how to simplify it. Okay.